Hello Purva, hello Sahil. Am I audible to all of you?
Yes, madam.
Okay. Is it possible for you to see the screen properly, my presentation?
Yes, ma'am.
Sahil, is it possible for you to see my presentation?
Yes, madam.
Okay, okay. Wait a minute. Full screen कसं करायचं दिसतं? कुठे झालं? Screen कुठे झालं? There are only 3 participants. Let me ask ma'am. We'll wait for 2 minutes. Otherwise, we'll start. Okay. Hello. Hello everyone. Tejal, Sahil and Purva. Am I audible to all of you? I'm asking it once again to you.
Yes, ma'am.
Okay, so we'll start because it's 4:35 almost, right? So we'll start. So today we are going to cover the 2 topics. First topic is light, shadow and reflection. And other topic is force and laws of motion. Okay. So first we'll go for the light, shadow and reflection, and then we'll move towards the force and laws of motion. Okay. So myself Shalaka Abhyankar. I will start with the topic light, shadows and reflection. This is basically a very basic topic which you must have studied in your 6th, 7th and 8th standards. But we are going to revise that topic once again. For light and shadows and reflection, first of all, we are going to see the source, that is the luminous object, the object that gives out or emits the light on their own, which is we are calling it as a luminous object. That means sun, which gives us the energy, light. Bulb or torch are the examples of the luminous objects. Non-luminous objects, they do not give out the light. Means how we can see that object? Because the light fall on that object, right? And that object reflect the light and we are able to see that object. Okay. So non-luminous objects are the objects which do not give out or emit the light on their own. That objects we are calling it as a non-luminous objects. Non-luminous objects are visible when light from other luminous objects fall on it. I've given shown here one example. There is one flower. When the light of the sun fall on it, we are able to see this flower. Okay. So non-luminous object do not give out or emit the light. It only reflects the light. Okay. Now we are going to see how the shadow will form. And to understand how shadow will form, we are going to see the three types of material. First material is your transparent material. The material through which light can pass completely. That material, we are calling it as a transparent material. That is glass or water. We can see through the glass. What is to that side of the glass? We can see that material. We are calling it as a transparent material. Now, opaque material, the material which do not allow light to pass through it. That means it stops the light. Okay. Suppose there is a one wall and you can't see behind that wall because the wall is opaque material. So wood, metals are the examples of the opaque material which do not allow light to pass to other side of that material. That material we are calling it as a opaque material. There is one more type of material which is your translucent material. Material through which light can pass partially. Means it will not, we cannot see the whole object. We can get just an idea of the shape of the object, but dimensionally, or if you want to measure its length and all the parameters of that object, it may not match. Example of that translucent material is tracing paper. You at least have a border, or you can see the outline of that object, but that object cannot be seen clearly by that material. That material we are calling it as a translucent material. So we have seen the three materials. First is your transparent material through which light will get completely passed. Okay, we can see the object which is other side of that material. The second material is your opaque material. So because of the opaque material, we are able to form a shadow. So how shadow can be formed? Opaque object do not allow a light to pass through them, right? So when the light source passes its energy or light, because the opaque material can't pass a light through it, there is a shadow or darkness which is formed behind that object. That object, that shadow, its shadow will get formed on that screen. Suppose, see, there is one source of a light, suppose a bulb. I have taken one sphere, or we can say a ball, and there is a screen which is behind that. The light source emits the light. Light will fall on this object, and because this object is an opaque material, the light will not get past through this area, and we can get a shadow of this object on a screen, right? So we can get a shadow on this screen of this object. Now the shadow will not be of the same size, and you can say that the shadow will give you the outer line, but exact object size is not get predicted, or you may be getting a false size by using the shadow. Now this girl is standing in a sun, and we are getting a shadow on the floor. So because of the opaque object, light cannot pass through it and we are able to see the shadow of that object. The things which are required to form a shadow, that means source of a light, opaque object and a screen is required to form a shadow. We can see an object around us because of the light. Because if there is a darkness, though we have our eyes, we cannot see the object if there is a darkness in a room, right? Unless and until light fall on object and that object reflects the light, we cannot see that object. In dark, no objects can be seen. And when we see the table or chair or the different objects which are present in our room, light will get reflected from it. Though table, chair, wall or different objects cannot generate the light, when the light fall on that object, they reflect the light from that object. Okay. Whenever we are getting the shadow will not give you the perfect information of the dimension of that object. Right? The shape of the object may changes, and this shadow may mislead us about the shape of the object. In the previous figure, we have seen the object was a sphere, and we are not getting the same size of the shadow on the screen. The shadow was bigger, right? Now, in the morning, sun is on your face. If you are standing in front in the morning on the floor, and if your face is toward the sun, shadow will be formed behind you. And in evening, if you are back, it will form backside, right? We are not able to get different colors for the shadow. So the color of the object changes, shadow will be of dark color, right? So shadow will not give you the perfect dimensions of that object. It may mislead regarding the shape of the object. Shadow form, when light form on an object, on an opaque object, necessarily the object should be opaque. It forms on the opposite side of the source. Now, in the previous figure, which shows the sun, the sphere, and the screen, if we change the position of your source, that means the sun will be on towards the right side, object is in the middle, and if we have a screen on the left side, then we will get a shadow of your sphere on the left side, right? So shadow will always form on the opposite side of the only outline matches to the object. As we have already seen, it will not give you the perfect dimensions. Brighter the light, darker will be the shadow. Okay. Now we are going to see pinhole camera. Basically, it's an optical device, and this pinhole camera will form an image of your object which is present in front of it without using any lens or any mirror. Okay, so pinhole camera is a simple camera without lens in the shape of a box. Here we can see in a figure, it is in the shape of a box. Here you can see there are two rectangular boxes. One is a smaller box and other is a bigger box. Okay, now there is a one small. How you are supposed to make this pinhole camera? There is a one box which is your outer box, and you can say the dimensions of this box will be bigger than this box. We will have a small hole to this box, to this edge of this box. Okay, there is one more box which is of a rectangular shape only, but size will be smaller, such that this box can fit inside this box. Okay, there is one rectangular hole which you are supposed to make for this box, and you are going to paste a translucent material or a paper to this box. Put this box inside this box and make, you can the dimensions of this right hand side box will be such that you can shift this box inside and outside freely. Okay, now what happens, this box will, when you look at the other side of from this edge, if there is one tree or if there is a fence see, or if there is any object, you can see the inverted image of that object to the other side. Okay, so there is a one tree, and this, suppose this is your pinhole box, then by using this you can get a inverted image of this tree. This image of the tree will be smaller, but that will be the inverted image. So without using any optical device, you will be able to see the image of the source. This is your pinhole camera. Now there are some characteristics, that is two characteristics of a light which we are going to see. First characteristic is light travels in a straight line. This is the first characteristic of your, one of the characteristics basically of the light, that light will travel in a straight line. For this we are going to have a simple experiment. There is one straw through which you can see there is one candle. The candle is lighted, and the person who is at to the other end of the this straw can see the light flame because the straw is in a straight position. Okay. Now, if I bend a straw in such a way, and again, if I try to see through the other end of the straw, I am not able to see the flame because light will not bend. It will not travel in a zigzag manner. It will always travel in a straight line. So this light will pass and it will go move away in a straight line like this. It will not bend and go like this. Okay. So from this experiment, we can conclude that light travels in a straight line. Okay, this is the one of the characteristic of the light. The second characteristic, that is a reflection of a light from a mirror, that we are going to see. This is a reflecting surface on which we are going to incident a light. The light which is perpendicular to this reflecting surface, which we are calling it as a normal. Light which is perpendicular to this reflecting surface, we are calling it as a normal. The ray which incident on this light, it's called as an incident ray. And when this ray incident over here at this point, this is a point of incidence. This point is called a point of, and it will get reflected in that medium only. And this ray which get reflected is called as a reflected light or reflected ray. Okay. Now we are supposed to measure an angle, and that angle should be measured between the incident ray and normal. And this angle is called as an angle of incidence. The angle between the normal and reflected ray, it is called as a angle of reflection. Okay. The Snells have given the laws for this, that this incident light, normal and reflected ray should fall in a one plane. Angle of incidence is equal to angle of reflection. Sine of I is equal to sine of I. Okay. So this is the reflection of light from the mirror. Now example of this reflection of a light from the mirror, you can see there is one cone and there is a gap between these teeth of the cone. This is the source of the light. Light passes and falls on the this mirror, and when it falls, the light will get reflected in such a way that you can see the shadow in this. Okay, this is the reflection of a light from a mirror. Now, this is another example for the reflection of the light. That is, there are three students which are standing in such a way that the student one, first student is holding a torch and he is falling the light from the torch on this mirror. As it travels in a straight line and falls on the mirror, it will get reflected over here and you can see the spot on the shirt of the second. Okay. So light travels in this way and it will get reflected because there is a mirror and it will fall. Okay. So this is called as a reflection of a light from a mirror. So summary of this presentation, we can like, light is a form of energy that makes things visible. The object which are not, which are non-luminous objects, which we are able to see when the light falls in on it and it will materials, that is transparent material, opaque material, and translucent material. If light fall on an opaque object, it will cast a shadow. Because opaque object is an object which can't pass a light through. So when we place a screen behind it, we can get a shadow. We have seen the two characteristic of the light. First is light travel in a straight line. For this, we have performed the experiment by using a straw, and light changes its direction after reflected from a mirror. We have seen the three boys which are present. They are not in a straight line. When the first boy spot a light on that mirror, it will get reflected from that mirror. It changes. Okay. So this is all for this presentation. Now, if you have any difficulty regarding this, which I have given you the presentation, you can ask me, or otherwise we'll move toward the second presentation. Do anyone have any query regarding this? Or should I share the second presentation? Yes. Yes, anybody have any problem with you? Anyone wants to ask anything? Okay, I'm sharing my second presentation. Wait. Is it visible to all of you? Force and Newton's law of motion.
Yes, ma'am.
Okay. Now, in this session, we are going to see force and laws of motion, that is balanced and unbalanced force, first law of motion, then second law of motion. And before that, we are going to define the term inertia and mass. Then we are shifting toward the third law of motion and conservation of the momentum. These points we are going to cover in this session. Okay. So first of all, what is meant by force? Force is the center of all the features, right? Which cause the object to move. Force is nothing but simple we can define force as a push or pull, which is applied to the object, which we can call it as a force, right? The force is nothing but an effort that changes the state of the object from at rest or at motion. Unless and until we apply a push or pull to the object, it can't change its position, right? It can change its, the object may change the direction, there may be a change in its velocity, or there may be a change in the shape of the object when we exert a force on it, right? Now, when we say that we are applying a force to the object, it is not necessary that two objects should be in contact with each other, okay? Because the gravitational force, there is no contact between the object and between the two objects, but that forces get applied. Okay, so bodies don't have to be in contact with each other to exert a force on each other. So for simplicity, we can say that force is nothing but an effort that changes the state of an object which is at rest, or the object which is in a motion. If we apply more force, it will increase its motion if the force is in same direction. Okay. There are two types of forces, that is balanced force and other is unbalanced force. If a resultant of all forces acting on a body is zero, then the force are called as a balanced force. Consider one object. I have kept a one box on a table. Now I am applying a 5 Newton of a force to that box from positive x direction. And if I am applying a force of 5 Newton to the negative x direction, then my forces will get cancelled out, right? So net force means total force, 5 Newton plus and 5 Newton minus. The net force on the object will be 0, right? So such forces are called as a balanced forces. And when I am applying a balanced force to the object, it will not change if the object is at rest, the object will be in a state of rest only, or if it is moving with some velocity, it will not change its velocity if I am applying a balance force. It will not cause any change in the motion if I am applying a balanced force. But when I apply an unbalanced force to the object, there may be a change in the speed, there may be a change in the direction or shape of the object when it is unbalanced. Right? Means again, if we keep one box on the table, the box is at rest when I'm applying a 5 Newton of a force from x-axis and my friend applying a 7 Newton of the force from negative x-axis, there will be a motion of the object to the negative x-axis with a force of 2 Newton. Am I right? So when I apply a balance force, then the object will change its position. Okay. So net, what is meant by net force? Net force is when I'm applying a multiple force to the object, then summation of that force, which I am calling it as a net force. Okay. So if the net force of the object is 0, then I can say that we are applying a balance force to that object, and if I am applying a balance force, the object will be in a state of rest. If it is in a state of rest, or the object is moving with some velocity, it will not change its velocity. And balance force cannot produce any motion, cannot stop the object, or cannot move the object if we are applying a balance force. So if you want to move the object, you have to apply a unbalanced force to the object. Okay. Now we are shifting towards the laws of motion. Newton gave 3 laws of motion, and these 3 laws which describes the relation between the forces which are acting on the body, and because of these forces, the motion which it causes, right? So we are going to see the 3 laws of motion, that is Newton's first law, second law, and third law. Okay. So among these, we are going to start with the first law. We'll see first the statement. An object remains in a state of rest or of uniform motion in a straight line unless it is acted upon by external unbalanced force. Now, we have seen the term what is meant by unbalanced force. Okay. So, what Newton has stated that if there is a one rock which is present in a middle of your road, and unless and until we apply a force, the rock will be present over there for years, right? So it is not going to change its motion. If it is at a state of rest, it will be in a state of rest. If it is in a uniform motion, then it will be in a uniform motion unless and until external unbalanced force which is applied to that object. Okay, so this is your first law of motion, which is also called as a law of inertia. So we are first law of motion, what it gives, it will give us the definition of the force. Because what is force? Push or pull, which is applied to the object. Right? Force is nothing but what? Which is going to change the state of rest or state of uniform motion, which is nothing but your force. So Newton's first law, which gives a definition of your force. Okay. Now we are going to see the next term, which is your inertia. Basically, it is also called as a first law of motion is also called as a law of inertia. So first we define that term, what that term is. Inability of a body to change by itself its state of motion is called as a inertia of your body. It's called as a inertia of your body. That means body on its own can't change its state of rest or state of motion along a straight line. When the object is moving in a straight line, it will not change its motion, or it will not if it is at a rest, it will not start moving unless and until a unbalanced force is which is given to the object. Basically all objects have a tendency to resist the change its state of motion. If it is in a state of motion or if it is in a state of rest. And this tendency of that object, which we are calling it as a inertia. Now, all the objects have same inertia? No. Because if I want to push a big rock, I have to apply more force, right? If I have to pick up full of, if I have to pick up the empty bucket, then I require less force. And if that bucket is full of water, I require more force, right? So more the inertia, more the force which is required, right? More the inertia, more force is required to change its position. If I want to push a toy car, which is present, now it will require very less force to pick up the toy car or to push the toy car. But if we are taking an adult car, which is loaded vehicle, it is very difficult for me to change its position, right? So inertia is nothing but if your mass of the object is more, the inertia will be more. It is more difficult for you to change its position. Okay. Now we are going to see one more term, which is nothing but your momentum. Momentum is nothing but product of mass and velocity of the moving object. Is a product of mass and velocity. So if the mass will be more, the momentum will be more. If mass is less, the momentum will be less. Same means momentum depend upon mass as well as the velocity. It's a vector quantity. Vector quantity means it requires a magnitude and direction to completely specify that quantity. Okay, means if we say that I have a momentum of 3 meter second. Okay, SI unit for the momentum kg meter per second because it's mass and velocity is meter per second. So I say that momentum of that object which is required to change its position is 3 kg meter per second. But unless and until I specified its direction, this quantity is not completely get specified. Okay, so momentum is a term which is nothing but your mass into the velocity, which is called as your momentum. Now, we are going to define, we are going to state a second law of motion. The rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of the. Now we have seen the different terms from this statement. Unbalanced force. We have seen what is meant by unbalanced force. We have seen the term momentum. Now we will see this law. Rate of change of momentum. Change in momentum means what? Final momentum minus initial momentum will be a change in momentum. Right. Rate of change of means rate means with respect to time. With respect to time means change in momentum upon time of the object, which is proportional to applied unbalanced force. The force, that means F is directly proportional to the change in momentum upon time, which is my second law of motion. What it gives, the second law of motion, what it gives? It will give the relation between force and acceleration. How it is that we are going to see. Okay. First law of motion is which help us to define the what is meant by force. Second law of motion which gives the relation between the force and your acceleration. Okay. Now, this is the explanation for second law of motion. There is one object whose mass is m, which is moving along a straight line with its initial velocity u. We know that the velocity for the term which is used to denote the velocity is u and v. U is your initial velocity and v is your final velocity. Okay. So mass, the object whose mass is m, initial velocity is u and final velocity is v. And the time through which we are applying that force will be t. F is the constant force which we are applying to the object and at time t. Okay. Now initial momentum. What is mean by momentum? Momentum which is denoted by P1. Right. This P1 is the symbol which is used to denote the momentum. Momentum is what? Mass into velocity. As we are defining the initial momentum, we are considering the initial velocity. So it will be m into u. Now for the final momentum of object will be P2, which will be m into final velocity. Final velocity will be u. So initial momentum and this is your final momentum. Okay. Have you got the term what is mean by momentum? Now, second law states that? Second law states that F is directly proportional to the change in rate of change of momentum. So we will first find out what is mean by change in momentum. So change in momentum means final momentum minus initial momentum. Okay. So final momentum is P2, initial momentum is P1. Here you can say that it is mv minus mu. So I have taken the m common. It will be v minus u. So this is change in momentum. Momentum means mass into velocity. Final minus initial. P2 is your final. P1 is your initial. Now rate of change of momentum. Rate of change of momentum means we are supposed to take a momentum with respect to time. Okay. So m v minus u upon t will be my rate of change of momentum. What second law states that force applied to the object is proportional to the rate of change of momentum. So, according to the second law, force is, this sign shows that it's a directly proportional. Change in momentum upon time. So, force is directly proportional to change in momentum upon time. I can put this term in this equation. So, m v minus u upon t. M v minus u upon t. So this proportionality constant, which I have kept it as a k. So m v minus u upon t. T is your final velocity, u is your initial velocity, and t is your time. So final velocity minus initial velocity upon time means rate of change of velocity, which is nothing but acceleration, which we have seen in our previous lecture. Acceleration is what? Rate of change of velocity, dv by dt. Right. Rate of change of means change in velocity, final velocity minus initial velocity upon time, which is nothing but my acceleration. So F is equal to K. This M I have kept as it is, and V minus U upon T is nothing but my A. So F is equal to KMA. K is nothing but your constant of proportionality. We can see that F is equal to A. Okay. So my second law of motion gives me the relation between the force. F is your force and A is nothing but your acceleration. Second law of motion gives a method to measure force which is acting on an object, as a product of its mass and its acceleration. Product of mass and acceleration. So formula for force which we are using, F is equal to ma. F is equal to ma. Okay. Do you want me to repeat this this derivation? Do anybody want me to repeat this derivation? Okay. Now we can see this second law of motion in our day-to-day life as when the fast moving cricket ball, when fielder tries to catch that fast moving cricket ball, he gradually pulls his hands in backward direction. You must have seen this. As the ball is moving in the direction of ball, but he tries to pull his hands in backward direction. Why it does so? Because when he does doing so, fielder increases the time, right? Because the velocity of ball is very high, and when it increases the time, velocity decreases, right? Velocity decreases and acceleration of the ball is also decreased. And impact of the catching of that ball, impact which will be on his hands, because the ball is moving very fast, its velocity is very fast, so that impact will get reduced. Okay, if he doesn't do that, the impact will be more and which may hurt his hands. Yeah. So you can say that this is the practical application of your second law of. Have everybody got this? Do you want me to repeat this derivation once again? We'll try to solve one numerical based on this. Wait, I'll stop this screen. Wait. You are visible the screen, no? Everybody can see the screen, numerical.
Yes, ma'am.
Okay. Now we'll try to solve one numerical which is based on Newton's second law of motion. Constant force acts on an object of a mass 5 kg for a duration of 2 seconds. It increases the object's velocity from 3 meter per second to the 7 meter per second. Find the magnitude of applied force. Now, if the force was applied for a duration of 5 seconds, what would be the final velocity of the object? First, we'll try to write a given data. Mass of the object which is given is a 5 kg, so m is equal to 5 kg. Duration 2 seconds, so t is equal to 2 seconds. Velocity, initial velocity which is denoted by u, final velocity is denoted by v. As it is given in SI unit only, no need to convert it into the other unit. If they have given it into CGS unit or different units, you have to convert it into the SI unit because mass is given in kgs. So what is the formula? F is equal to m v minus u upon t. So m is a mass, v 7 minus 3 upon 2, which is 4 by 2, which is 2 into 5, which is 10. So because of this, the force which is applied will be 10 Newton. Now, if the force was applied for a duration of 5 seconds, initially they have applied a force for 2 seconds. Now, if we apply it for 5 seconds, then final velocity will. Now, you have to convert this formula for final velocity v. So, what it will be? You are supposed to multiply this ft upon m plus u will be your v. So, this formula you are supposed to turn out for the velocity. So, u is 3. F into T. What is your F? F is equal to 10. T is your 5 seconds. So it will be 50 upon 5. So 50 by 5 will be 10. 10 plus 3, it will be 13 meters. Okay. We are seeing one numerical for the shift towards the third law of motion. Shift towards the third law of motion. Actually, the action reaction force, which is nothing but your third law of motion. What the statement states that whenever an object exerts a force on another body, the body exerts an equal and opposite force on the first body. This, whenever the forces which are get applied, which are in equal in magnitude but in opposite in direction. So, though they are equal in magnitude and opposite in direction, they will not get cancelled out because it will get applied on two different objects. That's why it is not get cancelled out. Because equal and opposite force, it may get cancelled out, but it is not getting applied on the same object. It will get applied on two different objects. So it will not get cancelled out. Okay. This law is theoretical law. There is no derivation for this law. So according to the third law of motion, every action there is an equal and opposite reaction which is present over there. Now, if you punch on a wall, right, you will get hurt, right? There will be a pain in your hand. Why it is so? Because when I'm applying a force on a wall also exert a force on your hand. Now, these two forces will be in opposite direction, but of equal amount, right? So, there will be a pain in your hand because you are applying a force on the wall, and according to the Newton's third law, every action will have a equal and opposite reaction. If I apply a force of 100 Newton, the opposite force will be of 100 Newton only. Okay. These two forces will not get cancelled out because I'm applying a force on wall and wall is applying a force on me, on my hand. Okay. So both the forces are of same magnitude, but these two forces are in opposite direction and they act on the two different objects. Okay. If there is one lady which is on wheels, if he exerts force on a wall, he is in opposite direction, right? Lady will push the wall. Yes. Anybody wants to ask anything? So when the lady pushes the wall applies a force on his hand in opposite direction. Magnitude will be same, and because of this, the lady will move in an opposite direction. When we throw a ball on the ground, it will be back in your hand because there is a backward force which will get applied on the ball. Okay. So what is Newton's third law? Body exerts a force on another body. The second body also exerts equal and opposite force on the first body. Okay. Now we are going to see law of conservation of momentum. We have seen the momentum. What is meant by momentum? Momentum is what? Mass into velocity. Okay. This is the one of the fundamental law and which is a very important concept in new mechanics. The application of second and third law of motion, which is nothing but which plays a very important role actually in conservation of the momentum, right? What this law is, the statement of the law is sum of momentum of two objects before collision. Collision is equal to sum of momentum of the collision after collision, provided there is no external unbalanced forces acting on them. Means if we take two spheres, the spheres are moving opposite to each other, and if they collide with each other, then it's their momentum before collision will be same as their momentum after collision. It is nothing but law of conservation of the momentum. Conservation means remain constant. What remain constant? Their momentum remain constant. Whose momentum remain constant? The objects which are colliding with each other, their momentum. Momentum means sum of the multiple product of the mass into velocity. Okay. No net momentum will be act. It is conserve means remain constant. There is no change in the momentum, which is nothing but a law of conservation of the momentum. Okay. The two objects which are colliding. The first object whose velocity is as its initial velocity before collision. So we are taking a object m1, mass m1 and mass m2. Velocities will be u1 and u2, right? So m1 u1 plus m2 u2 is the sum of the momentum before collision. Mass is not going to change, their velocities changes. So V1 and V2 will be their velocities after collision. Okay. So M1 V1 plus M2 V2 will be the sum of the momentum after collision. And M1 U1 plus M2 U2 will be equal to M1 V1 plus M2 V2. This is nothing but a law of conservation of angular, law of conservation of the momentum. Okay. Now, there is an explanation or a derivation for the law of conservation of momentum. Let M1 mass of a particle A, which is colliding, M2 mass of a particle B, which is colliding, U1 V1 the velocities of the initial and final velocity of the A, U2 V2 will be initial and final velocities of the particle B. Okay. Now let these two particles be in contact for the time t. Means if they collide for the time t, change in momentum will be what? Final minus initial. Change in momentum of B will be what? Final minus initial. Right. So FBA, which is the force applied on A because of the mass B. Force AB is force applied on a B because of the mass A, which will be equal and opposite, which is nothing but your third law of motion. When two objects are colliding, equal and opposite force will get applied. Now, FBA, which is nothing but mass into acceleration. F is equal to force is equal to, so M2A2. A2 is what? Acceleration, rate of change of velocity, which will be V2 minus U2 upon T. FAB, which will be your before collision. So it is M1A1, mass into acceleration. Mass will remain same, M1. Acceleration is the rate of change of velocity, which is your initial velocity. So we are using a V1 and U1 as well. Okay. Now, what we are saying, it is M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Right. That is nothing but FBA is equal to minus of FAB according to the Newton's third law. So M2 V2 minus U2 upon T, which is your FBA, is equal to minus of M1 V1 minus V1 upon T. Okay, this TT will get cancelled out, both sides. Now, if you multiply this inside and take the term U1 to the left side and V1 V term as the right side. So see this M2 V2 minus M2 U2 minus of M1 V1 plus of M1 U1. Okay. So this M1 U1 and this will be in minus term to the left side. So if you take it to the right side, it will become plus. Again, M1 V1 plus M2. If you solve this, you will get this. M1 U1 plus M2 U2, which is a total momentum of particle A and B before collision. M1 V1 plus M2 V2 is the total momentum of the particle after collision. So we can say that this is a law of conservation of momentum. This is your law of conservation of momentum. Okay. The example of law of conservation of linear momentum, which is bullet fired from a gun. M1 is a mass of the bullet, M2 is a mass of the gun. V1 is the velocity of the bullet and V2 is the velocity of the gun. Before firing the gun, gun and bullet both are at rest. Hence, total linear momentum is 0. Total linear momentum after firing will be M1 V1 plus M2 V2. So, by using this law of conservation of linear momentum, we can calculate the velocity of that gun. Okay, V2. So, before collision, it will be 0 because both are at rest. So, there will be not a velocity will be 0. So, it will be 0. M1 V1 plus M2. So, this will become M2 V2 is equal to minus M1 V1. V2 will be M1 upon M2. This is the law of conservation of example of the law of conservation of linear. Again, we'll see one example numerical which is based on the conservation of linear momentum. girl of mass 40 kg jumps with a horizontal velocity of 5 meter per second onto a stationary cart with a frictionless wheels. The mass of a cart is 3 kg. What is her velocity as cart starts moving? As in that there is no external unbalanced force working in a horizontal direction. Okay. They have stated that frictional force because if that amount of force will get added, then your calculation will be different. Okay. So they have stated that you are not supposed to consider the frictional force. Total momentum of girl and cart before the interaction. So M1U1 plus M1V1, right? It will be 40 into 5 plus 3 into 0. That will be 40 into 5 will be 200. Total momentum after interaction. Now, the girl's weight is 40 kg and cart's weight is 3 kg. So it will be 40 plus 3 into V. So 43 V is equal to, it is getting conserved. That means initial momentum and final momentum will be same. So 43 V is equal to 200. So V is equal to 200 upon 43, which is 4.65 meter per second. Okay. This is nothing but an example of law of conservation of V. So this is all for this presentation. Wait a minute. So we'll revise it once again, what we have seen. Share my PPT once again. So we have started with force. Force is nothing but push or pull, which is applied to the object, which will change the state. The state may be a rest or it may be in a motion. There are two types of forces. First is your balanced force and other is your unbalanced force. Balanced force will not cause any change in the motion or the object is in at rest, it will be in a rest. But unbalanced force will change the position of the object. Okay. Next, first law of motion. An object remains in a state of rest or uniform motion unless and until external unbalanced force which is applied to it. Then inertia, then one term which is called as an inertia of the object. This inertia is also known as a first law of motion or law of inertia. It is the all bodies do not have or all bodies resist or tendency to resist change in the state of motion or a rest. This tendency which we are calling it as a inertia. Okay. This inertia will depend upon its mass. If mass is more, your inertia will be more. If mass is less, your inertia will be less. Okay. For this, we have seen the example. If I want to push a rock which is present, which is very huge, I will require more force because mass of that object, that means inertia of object will be. Okay. Next term we have seen the momentum. Momentum is nothing but what? Mass into velocity. It's called as a momentum. It's a vector quantity. SI unit of momentum will be what? Mass is measured in kg. Velocity is measured in meter per second. So kg meter per second will be your second law of motion. That is the rate of change of momentum. Change of momentum final minus initial rate means with respect to time. So change in momentum upon time will be your force. Rate of change of momentum of object is proportional to the applied force. Is nothing but your second law of motion. I've given you the example of the catching of a cricket ball. This second law of motion, which will give us a relation between the force and the acceleration. Okay. Now this is the explanation for the second law of motion, or derivation you can say. Momentum is equal to mass into velocity. Initial momentum and final. Okay. Then change in momentum P2 minus P1 mv v minus u, because P2 is equal to mv, P1 is equal to mv. Rate means you are supposed to divide with time, which is nothing but it is proportional to the force. We have kept a proportionality constant as a k, and v minus u upon t is nothing but acceleration, rate of change of velocity is your acceleration. So kma is nothing but force is equal to ma. Then we are seeing one numerical. I already explained you. Next is third law. Third law is a theoretical law basically. It doesn't have any derivation for it. Every body will have means each action will have an equal and opposite reaction. Whenever a body exerts a force on another body, second body also exerts an equal and opposite force on the first body. The force will be of same magnitude. It will be in opposite direction and acts on a different objects. Okay. Then law of conservation of momentum. Law of conservation of sum of the momentum of an object before collision will be equal to the sum of the collision of the object after collision, and provided that there is no external unbalanced force which is acting on the body. Here is the derivation for it. So change in momentum of object A and B will be m1 v1 minus v1, and for object B m2 v2 minus v2. According to the third law, FBA minus FAB. Have you got this term? What is BA and AB? It is a force which is applied by the object B on the object A, and this is the force which is applied by object A on the object B. It is in opposite direction, therefore it is the negative sign. So M2A2, that is M2V2 minus U2 upon T, M1V1 minus U1 upon T. As FBA is equal to FAB, so here if you try, PT will get cancelled out, and it is M1U1 plus M2U2 will be equal to M1V1 plus. This is nothing but a law of conservation of. Bullet fired from a gun is an example for the law of conservation of the moment. And here we are seeing numerical based on this. Do you have any query regarding this now? Do you want any answer for regarding this PPT or this laws of motions? Three laws of motion. Yes. Have everybody got these three laws? The term inertia, momentum, law of conservation of momentum. Have everybody got this? Yes, Modal, Pradnya, Purva, Sahib, Asian, and Vaishnavi. You got that numerical also. Whenever you are going to solve the numerical, please see to it that the numericals, all the parameters should be in one standard units. Basically, you are supposed to convert it into the SI unit. That will give you the correct answer. Okay. So, should we stop this meeting now? Should I end this meeting now? Okay. I'm ending this meeting.